Ladies and gentlemen, welcome to my presentation. My name is Wayan Wangiana from the University of Mataram in Mataram, Lombok, Indonesia. The title of my presentation is Mycorrhiza Biofertilizer and Intercropping with Soybean Increase Anthocyanin Contents and Yield of Upland Red Rice under Aerobic Irrigation System. I prepared this paper together with two other colleagues, namely Mulyarta Aryana and Dwiyani Dulur. To start with, I will introduce different types of rice, especially based on the shapes and the color of the kernels or the seed coat. And based on the color of the seed coat, there are white rice, which is the most common rice that we normally eat. But in addition, there are also yellow rice, which is called golden rice. There are brown rice, red rice, purple rice, and black rice. The intensity of the color depends on level of anthocyanin content in the grain. Anthocyanin has a high antioxidant activity, so consuming red or black rice is very good for our health. What is mycorrhiza? Mycorrhiza is a symbiosis between specialized fungi, which is called mycorrhizal fungi, and plant roots. Crop plants in symbiosis with mycorrhiza, such as arbuscular mycorrhizal fungi, will be able to take up more nutrients and water from soil, especially from marginal soils, for better nutrition and yield potential. We have also reported that application of mycorrhiza biofertilizers could increase anthocyanin content of various red rice genotypes. But the most common advantages of applying mycorrhiza biofertilizers to crop plants is for better nutrition and plant water relations in order to increase growth, yield of crop plants, including rice. What is aerobic rice system? Aerobic rice system, or IRS, is very different from the conventional rice system, which is normally flooded. When the farmer growing rice, the rice is flooded by irrigation water. In IRS, soil is not flooded, not puddled, and not saturated with water. Irrigation water can be applied through furrows between rice beds or using sprinkler irrigation. In addition to better mycorrhizal conditions of aerobic rice compared with conventional rice, aerobic cultivations will enable the farmer or rice grower to grow rice in intercropping with legume crops, which are capable of fixing atmospheric nitrogen in symbiosis with Rhizobium bacteria for better nitrogen nutrition of the rice plant and higher contents of the soil, higher end content of the soil. Growth and yield performance of red rice under aerobic systems are also much better than under conventional systems, as you can see from the picture, especially the number of tillers are very different. The objective. The objective of this study was to examine the effect of intercropping red rice with soybean and application of Mycorrhiza Biofertilizer on anthocyanin content and yield, as well as yield component of two upland red rice genotype. This study was a part of a 3-year research project funded by the Directorate General of Higher Education. The methods. For this objective, a field experiment was arranged according to split plot design with 3 treatment factors, namely, factor number 1 was upland red rice genotypes as the main plot, consisting of G4 and G10. Factor number 2 was intercropping red rice with soybean as the subplot factor, consisting of T0 without intercropping and T1 intercropping with soybean. And the third factor was application of Mycorrhiza Biofertilizer as the subplot factor, consisting of 2 treatments which are without Mycorrhiza application and with application of Mycorrhiza Biofertilizer. Each treatment combination of the 3 factors was made in 3 blocks as the replication. The results. The results of analysis of variance or ANOVA are summarized in Table 1. Based on the ANOVA results, there were two-way and three-way interaction effects of the treatment factor, especially on the percentage of field grain number and anthocyanin concentration. There were also significant effect of each treatment factor, and among the treatment factors, application of Mycorrhiza Biofertilizer shows the strongest effect, followed by intercropping, and the least significant effect was the difference between the rice genotypes, which showed differences only in grain yield. Let's look at the main effect, which is summarized in Table 2. Based on the main effect in Table 2, we can see that application of Mycorrhiza Biofertilizer could significantly increase anthocyanin content and all yield component of the red rice, so that the intercropping with soybean, except for the percentage of field grain number per clump. But between the two genotypes, the significant difference was only in dry grain yield. We look at the interaction effect. First, we look at the two-way interaction effect. Figure 2 shows that both genotypes of red rice responded differently to application of Mycorrhiza Biofertilizer. G4 did not show significant difference, no significant effect of application of Mycorrhiza, but G10 show significant difference. So does the response of the red rice on application of mycorrhiza and intercropping. Without intercropping, application of mycorrhiza shows very significant difference. But with intercropping, the difference, although it was significant, but in lower degree. However, when we apply mycorrhiza, there was no significant difference between intercropping with soybean or without intercropping. But without application of mycorrhiza, intercropping also capable of increasing field grain percentage of field grain number of the red rice. In relation to three-way interaction effects on percentage of field grain number, we can see the different response between both genotypes. In G4, without intercropping, the response to mycorrhiza application was very significant. Mycorrhiza application very significantly increased percentage of field grain number, but not when G4 was intercropped with soybean. However, without application of mycorrhiza, intercropping with soybean significantly increased percentage of field grain number of G4. For G10, however, the response to mycorrhiza application is very consistent. Whether or not rice plant were intercropped with soybean, but without application of mycorrhiza, there are no differences between intercropping with soybean and without intercropping. Conclusion. Based on these results, it can be concluded that both application of Mycorrhiza Biofertilizer and intercropping with soybean could significantly increase grain yield of the red rice. Yield component and anthocyanin content in the husked grains of the upland red rice. Therefore, the implication is that these treatments, in addition to increase grain yield, are also capable of increasing health values of the grains through an increase in anthocyanin content. Thank you very much for your attention.